Session we will see about 4 by 1 multiplexer. A 4 by 1 multiplexer will have 4 inputs and 1 output. First we will see the logic symbol. So this is a 4 by 1 mux. Therefore we have 4 inputs I0, I1, I2 and I3. So these are the 4 inputs. In order to select 4 inputs, we need 2 select lines. Let it be S1 and S0, because using 2 select lines we can have 4 combination, that is S1 can be 0, S0 can be 0, S1 can be 0, S0 can be 1, S1 can be 1 and S0 can be 0, and both S can be 1. So there are 4 combinations to select 4 inputs. We can select each input for a combination. So how many outputs we will have? We will have only one output in a multiplexer. We will see the truth table. In truth table of multiplexer, we will draw the select lines and the output. So the select lines I have already mentioned. It can be 0, 0, 0, 1, 1, 0 or 1, 1. So these are the select lines. So if it is 0, 0, we can assign to any input. When the select line is 0, 0, we can tell which input should be available as output. Either it can be I0 or it can be I2, any input. It's our choice. As per our design, we have to create or we have to draw the logic diagram. So for simplicity, we can maintain the order of input. In 0, 0, let I0 will be at the output. When S0, S1 and S0 is 0, we will get the output as I0. Whatever be the value in the line I0, we will get in the output. We will not get the values in I1, I2 and I3 at the output when S1 is 0 and S0 is 0. Similarly, in the next case, that is if S1 is 0 and S0 is 1, we will get I1, input I1 at the output. No other inputs will be passed through the multiplexer to the output during this case. When S1 is 1 and S0 is 0, we will get I2 at the output, and finally when both select lines are 1, we will get I3 at the output. So the order is not important. We can select in which all condition which input should be available to the output as per our needs. So here I have maintained the order I0, I1, I2, I3 as per the select line. Now we will write the equation of output y is equal to. So in the output y, we will get all the inputs, isn't it? We will get I0 or I1 or I2 or I3. We will get all the inputs. So when we will get I0, and remember that we will not get all these inputs I0, I1, I2, I3 at the same time. At a time we will get either of these 4 input at the output. So when we will get I0, we will get I0 of the output only in this condition. That means when S1 is 0 and S0 is 0. Now OR condition, that is plus, we will get I1 also. We will get I1 only when this condition, that means S1 is 0 or S1 is 0 and S0 is 1. Similarly, we will get I2. We will get I2, that is plus I2 only when this condition. That means S1 is 1 and S0 is 0. And we will get I3 at the output only when both S is 1. So, this is the logic expression of 4 by 1 multiplexer. We will draw the logic diagram. We have two select lines. First we will draw the select lines, that is S1. We will also draw the inverted value of S1, that is S1 bar. We have S0 and also we will draw the inverted value of S0, that is S0 bar. So, we have 4 AND gates, we need 4 AND gates. So, we will draw the 4 AND gates. This is first one, second one, third one and the fourth one. So, we have drawn the 4 AND gates and we need an OR gate to add all these terms. So, this is the final output. So, what is the first AND gate? It will multiply I0, S1 bar, S0 bar. So, we will draw, this is S1 bar, this is S0 bar and we have the I0. Now, the second AND gate, you have I1, then you have S1 bar, S0. So, this is S1 bar and we have S0. Now, in the third AND gate, you have I2 and you have S1, S0 bar. So, this is S1 and we have S0 bar. And the final AND gate, you have I3 and you have both S1, S0, S0 and S1. So, this is the logic diagram for 4 by 1 multiplex.